Hey guys, this is Renan with Piece of Pie Learning, and today I will show you how to solve a system of equations using the elimination method. So just a quick recap, that a system of linear equations is when you just have more than one equation and they're both straight lines. So in this case, this is equation 1 and this is equation 2. Further, if we were to graph each one of these, this is how it would look. Finally, for the recap, the point of intersection between them will be their solution, right? And in this case, that should be 4 comma negative 1. So don't forget, point of intersection is the solution. Now, let's solve this algebraically. So the first thing I'm going to do is erase the 1 and 2 because that's in the way. Now, the real first thing I'm going to do is I will multiply the second equation by 2. And I'm going to explain why I'm doing that right now. So if you multiply that whole equation by 2, it becomes negative 2x plus 6y equals negative 14. I'm not going to go into detail as to why I'm allowed to multiply it by any number, but just know that you're allowed to multiply any equation by any number, and it will maintain that equation. Like if I graphed negative 2x plus 6y equals negative 14, it would be the same equation, the same line, as negative x plus 3y equals negative 7. If you don't believe me, try it out on Desmos, and you will see that it is true. So the whole purpose of multiplying it by 2 is so that now this term, negative 2x, is the exact opposite as 2x. So I'm going to rewrite this one right below it. 2x plus 5y equals to 3. Right? So I just kind of switched them. Because of how I set it up now, if I go and add these equations, right, the negative 2x and positive 2x would cancel. It would become 0 technically. Most people don't write the 0. And then you just add the rest. 6y plus 5y is 11y. I'm just going to put the plus here for consistency. And negative 14 plus 3 is negative 11. At this point, you just solve, right? So that's 11y equals negative 11. Divide by 11. And y is equal to negative 1. Once you get y, you plug that back into either equation. I'm just going to plug it into the top one just because. So plus 5 times negative 1 equals to 3, and you solve, right? So 2x minus 5 equals 3. You add the 5 over, and you get 2x equals 8, which means that x is equal to 4. Boom, confirmed, right? 4 comma negative 1. Now, a lot of you might be wondering, like, well, you know, how do I know when to multiply by, or how do I know what to multiply by? And I think doing this second example might help you understand that. So let's go straight to that. So in this equation, again, we have both equations, or 2 equations, right? And I'm going to go ahead and eliminate y because I already see that one of them is positive and one of them is negative. So that'll make my life a little bit easier, right? If that's not true, then you're going to have to multiply by a negative. So actually what I can do is in the next video, I'll solve this same equation, but I'll eliminate x, right? Or maybe I'll do it in this video. We'll see. But for now, I'm going to eliminate y. Now, in order to do that, remember that my goal is to get the y terms to be the exact opposites, right? They have to be the same number, but opposite signs. These are already opposite signs. But in this case, 4 is not a multiple of 3. So it's not like this one where it was a simple multiplication by 2. In this one, you actually have to multiply each one by a number. And in fact, it's by each other, right? So I'm going to multiply the top one by 4 and the bottom one by 3. And I'm going to rewrite them. 8x plus 12y is equal to, oh, Lord, 40 plus 16, 56. I hope I did that right. My mental math game is weak, guys. I'm sorry. Equals 12. Now we can just add the equations, right? And as you can see again, this will cancel out. 9 plus 8, 17x is equal to 68. Divide by 17, divide by 17. I'm on the spot right now. That's going to be 4. Boom. And as you can see, boom, look, at x is 4. They intersect, baby. They intersect. So 4, it should be 4 comma 2, right? So now to get that y value, you plug 4 into whichever one. I'm going to plug it into the top one. So you're going to get 2x. Let me move this. Oh, no. Messed up, guys. So 2 times 4 plus 3y equals 14. That's 8 plus 3y equals 14. Subtract by 8. Move it over here. 3y is equal to 6. Divide by 3. And y is equal to 2. As we had said, we have confirmed the point of intersection algebraically. If you're still unsure how to do these, I will post more videos. For elimination, honestly, it just takes a lot of practice and seeing a lot of different examples to get a feel for it. But the main takeaway is that you're allowed to multiply either equation, right? You can multiply either equation, one of the equations, or both of the equations by whatever number you want. But the goal is to make sure that the variable you want to eliminate, in both equations, you want the terms to be opposite. So like, let's say we had, just a quick example here so you can understand. Let's say I had another one. Let me put this right here. Let's say I had x, I'm put an easy one, plus y equals 3. And then the other equation was 3x plus 2y equals 5. So in this one, I could multiply the top. Let's say I want to get rid of x. I could multiply by -3. Why? Because -3 times x would make it, I'm going to write it down here, -3x minus 3y equals -9. And when I add this, these would cancel. Right? So just remember what the goal is, guys. You need opposite terms for the variable you want to cancel. And then once that's done and you cancel the variable, add everything else up, solve for the variable that you're looking for, plug it back in, get the other one, and boom, done. Peace.